Hello, good morning. Welcome to the class ECE451. This is a control engineering class. Today this lecture is for the 6-week Monday class, and I have to make some change here. In the syllabus, I said the second midterm exam I scheduled at 7th week, and now I will move it to the 9th week. Yeah, according to the material they studied. I think we can have it on the 9th week, Monday of the 9th week. All right, and then in the 8th week, in the Wednesday of 8th week, we can have a review. We can have a review of that, of the exam. All right, let me write here. So ECE451. This is for the 6-week Monday class for the midterm schedule. Midterm exam 2. There will be in the 9th week, Monday, and the review in the 8th week, Wednesday. Maybe I don't need the whole class for the review, but I will have a review in that day. All right. And okay, this is for second midterm, and the third midterm. I already put some time in the syllabus, but maybe I will change it. And yeah, depending on the process. All right. Okay. Today we will keep working on the rule locus. So the problem is suppose we have a feedback system. The structure looks like this. This is a form just for the rule locus, right? If you want to consider a system, you want to change some parameters, then you need to rewrite the system in terms like this way. All right. We have this one. Then we can change. We can have orbit of the poles of the whole system, and that gives us the rule locus, right? Okay. Last time we have discussed the departure and arrival direction of the rule locus, and to do that we need that formula. Actually, we have that. We always have that. If S is a point on the rule locus, we have 1 plus k g of s equal to 0. We have this one. Or g of s equal to -1 over k. We use 1 for this. Okay. Actually, for the departure problem, for the angle problem, we need this. And for convenience, we suppose g of s equal to s minus 0, 1 times until s minus 0, how many zeros? Suppose m zeros, and divided by s minus 1 until s minus n. Suppose n poles. All right. And here maybe we have a constant, or maybe not. Okay, I put it here. Maybe a. In most cases, a is just 1. Here, suppose a is a positive number. Suppose we have this one. Then this equation 1, we can rewrite it in terms of angles. By 1, we have the angle of s minus z1 plus angle of s minus z2 minus s minus z1 s minus z2 angle of s minus zm, and okay, in the numerator then the multiplication it is just you add a summation plus, and here's divided by these terms, then the angle way that is subtract, so this is minus angle of s minus p1 minus angle of s minus p2 minus minus until s minus p n. Then the other side were equal to, because a is a positive real number, so the angle of a is just 0. So here we don't need, right? You add angle of z, it's nothing. Then equal to the other side is angle of negative 1 over k. This angle will be 0 or 180, depending k is positive or negative. If k is positive, this will be a negative value, right? Negative value, the angle of negative value will be 180. Okay, we have this one. And then how to determine the angle? We want for the direction, right? We already have several directions. Direction one is a departure from pole, from a pole pi, right? It's a pi, or arrive to a 0, to a zi. Okay, we have these two angles. And actually we can also consider the arrive, the direction arrive to pi, or the direction departure from from the zi, from the 0. And we can also consider these two. Now we don't know. We already have these, but we do not know what are these two. Alright. Now how to find them? Actually they are working in a similar way. And give the formula. So like this, we consider the first one. What is this? Remember? Okay, suppose this is a pi. And we have another pole pj, all the others. I just put one, but actually it should be depend, maybe a lot. Right? pj different with pi, and the zeros 0j. Alright. Then the direction. Suppose we have the locus go to somewhere here, to S0. Then this give us the direction, right? This give us this direction. I use theta to denote it. Theta is the direction. And this S0 according to some k positive. And here is k equal to 0, right? When k is 0, the locus start from the cross, from a pole, right? Pole of G. So this is k equal to 0. Here's a k is larger than 0, right? And we connect here. We have this angle. This angle actually it is one of these, right? One of these from S0 to some pj. But we replace this angle by this angle. This is the angle from not from S0 to pj. Now it's pi to pj. This line. We want this angle. But we can think these two angles almost the same. I use the notation pj, theta j for it. Theta j equal to another theta j. I both use theta j, but different angle. I have two angles, right? We think they are same, almost same. And as a limit should be same, right? If this is a very small number, when S0 as a limit, go to limit and use pi as limit, then these two actually same. All right, and similar we can also consider these two. Here we also have two angles. right? Two angles, and we think they are same. I just denote it as verify j. Okay, now we have the formula. I just rewrite these. I call these as 2. I rewrite 2 by 2. We have the angle of S0. Okay, this theta, phi I, right? Phi j, and do summation. So summation of all the phi j, and minus this theta. This verify. This is verify. This is phi. Also phi. This also this kind of phi. All those phi j. I don't need an angle actually. All those phi j. Phi j do not equal to pi. Okay. Then this angle S0 to pi, I just use theta, right? Theta. So minus theta, but theta might be this pi has a multiple q, and equal to this side angle of these. Okay, we know S0 here is k is positive, right? K is positive, so this place will be, this should be negative. Then here's a pi, and now of course you will think any 2k pi will be fine for any k, right? For any k. All right. Then we have theta j, q theta, not theta j, q theta, or equal to summation of this verify minus the summation of this phi. Verify is according to zeros and phi according to poles, and the minus of pi or plus, doesn't matter, right? You pi move to that side, and 2k pi for any k, right? For any k. Of course, when k is 2q, divide by q, that is 2 pi. You go back, right? 2 pi is go back. Yeah. So actually 0 to q minus 1, that will be enough. If k is equal to q, that means same as k equal to 0, and the larger k were equal to some number here. So we suppose k just run from 0 to q minus 1. You divide by q, you can find theta. And similar. If we consider a circle, a zero, and the cross, this is a zi, some zi, and all the other zeros, zj, and all the pj's. Then we have similar. We consider this angle. Here's a verify j, here's a phi j, and this one we need a direction. Suppose here's a S0. Then this is theta. Okay, we have similar formula. We have it's a q theta. Okay, this theta is a departure, and this theta is a arrive. All right, this is arrive. Go from this way, and here this k should be positive, right? K positive. Actually, this point is k is infinity. But I need to use this k, right? K is positive. So we still have similar formula. But let me see. I need this q theta will be part of this. Now q theta is not this one. Q theta is a part of this. Yeah, q theta here should be plus, right? All of these are plus, so here should be plus. In this way, here should be plus. Then just move these to that side, right? So we have negative of these verify and positive of these phi, and here's plus pi plus 2kg pi, and the k is also you just 0, 1 to q minus 1. That will be enough. Okay, so this is for the arrive to a 0. This is direction arrive to a 0, and this is a depart from PI. This is arrive to a 0 ZI. Right? Okay. And now we consider the other two. Similar with this. Actually, we use same formula. Just the location different. K is also different. Right? K is also different. Now we consider arrive to PI. Arrive to PI. Similar thing. We have PI here. This one according to K equal to 0. Now we have some S0. Arrive to here. We want this angle theta. But this S0 is what? According to K negative. Okay. This is K0. So when K increase, right? Increase to PI. So increase to 0. So this K should be negative. This is just different here. Similar with this case. Similar with the arrival departure case. Just this K is negative. K is negative. Right? Similar with this. I give the graph. We have a 0 here. Another, all the other PJs, and this is a Z, a ZJ. Then we have angle here. This is a phi J, and the angle here. These are the phi J. Okay, and PI. We also suppose this has Q, has multiple Q. I still have this. Oh, I forgot to write that one. Yes, that's it. This Q. PI has multiple Q. Right. Yeah, this one is ZI has multiple Q. Right. Okay. Then now we still by the equation 2. Equation 2 by 2. We have summation of all these ver j minus summation of all of the other here's a cross, another poles, all the other poles, right? And minus this angle, minus Q times that theta. That's it. We're equal to the angle of 1 over K, negative 1 over K. But K is negative. So this is positive. So this is just 0, right? It's 0. K is negative. So this is the angle of negative 1 over K equal to 0. We have this. And of course plus 2K pi. 2K pi. Okay. So we have Q theta equal to summation of all those phi j minus all those another the ver phi j and phi j, and minus or plus, doesn't matter. I use the same form, same way. Here is plus. Okay, I still use plus 2K pi, and K run from 0 to Q minus 1. Okay, so we have this theta. This is the theta arrive to a pole. We can compare with the departure. You see, the only thing different is the pi, right? This part the same, and this part the same. Here is also same, right? We have this three same. These three are same. And these three are same. Just for departure you have a negative pi here, and here's no that pi. And if we divide by Q, then you know it's a Q. I will say, yeah, I will show you in the MATLAB. Okay, so the things like across, you have departure, departure if q is 3, and arrive like this, equilaterally. The angle will be equilaterally. This will be pi over q. The angle here is pi over q. So we have 3 directions coming in and 3 directions coming out. Just look like this. Alright. Yeah. And a similar thing for the zeros, departure and arrive zeros. This is arrival to P and departure from 0. Similar to because this is 0, we have all the other zeros and all the poles. These are Pj, these are Zj, and this is the Zi we are calculating. And we have this angle is ver phi j, and this angle is phi j, and here we have S0. We want this angle theta. Now it's a departure, so it should go this way. Okay, this k is a negative value, and this one k is a, you think it's a negative infinity. So k is a positive infinity and negative infinity. That will be the same point. Okay. All right. Then we can have a formulas. I will write this formula similar. So we have zi. Suppose zi has multiple q. Then q times this seat will equal to, this will be negative ver phi. Yeah, similar with this, just change the direction of these two. So it's negative ver phi j and minus a plus phi j. Right? We still have this. Just here is a plus, right? So you move that to that side, you get this one, and plus 2k pi, and k is also round from 0 to q minus 1. All right, so this is for departure from 0. And at 0 the things were similar like this. Similar if q is 3. If q is 3. Departure, that means k negative, and the coming is k positive, right? And this one is coming, k is negative, and departure, that means k is positive, right? Things like that. Okay, so these are the poles and zeros when the locus leave or arrive to poles or zeros. We can calculate the direction. All right. We can use an example to see what happened. Suppose g like this. G of s equal to s plus 2 s square s square plus 2s plus what? Plus 10. Okay, plus 5. Alright, plus 5. So we have 0 at negative 2, and the pole at negative 1 plus 2j, right? This is 1 plus 4. So s squared plus 2s plus 1, according to that negative 1. And 4 is 2 squared. Actually, I have 2 here. 2 here. So 1 cross here, 1 cross here. Right? Alright. So this is g of s, the PZ map. PZ map of G is this one. Then the root locus. What is the root locus of this? It will start from these two cross. Is 2j negative. This is to J positive, and here's 1. And the negative 2, we start from here, and this is one end. The other end will go to infinite, right? We only have one root locker will go to infinite, so the only direction will be this way. Okay, start from here. 1 go to infinite, 1 go to here. So it must be like this, right? Go to here, then separate. Go to here, then separate. Like this, right? Separate. Actually, we know this is break point, right? And this direction and this departure direction. Can we know this direction? We can check this one. We say this is suppose this is theta 1, and this is theta 2. Actually, symmetrically, you know, this must be negative theta 1. So we can find 1. That will be enough. And what is theta 1? You see, this is I gave again. Find theta 1. It will be across here, a 0 here, right? We need this angle. We need this angle. So this is a phi. This is a verify. We only have one phi, one verify. And here's the direction theta, right? So theta equal to phi minus verify plus or minus pi 180. I use 180, and plus k times 360. And the q, here's q is 1, so we don't need it. I only need k0 is fine, right? K0 is fine. So it is just this one. This is 90. Phi is 90 degree, right? This is 90 degree. And what it is? This is 1. This is 2. Okay, I just leave it theta, right? Some theta here, some theta here. So this will be theta phi, some phi here, some verify here. Verify minus 270. So this is verify. Here's a 2, here's 1. This is verify, and minus this one. Okay, so it's plus 90 degree, right? Plus 90 degree, plus 90 degree. Okay, so the direction will be this. You connect these two lines, these 2 points, the cross and circle, and use 90 degree here. This is direction. This is direction. So here, this direction, and symmetrically, you connect them, and 90 degree here. This will be this direction. All right. And you can also calculate this. I think it will be go along the real axis, but actually, if you check this angle, like this is a theta, another theta, then theta third will be, you'll consider you have cross, then you have this angle, this is a phi 1, this is phi 2, no verify, no all the other, only 1 0 I use, so no more 0, so no phi, only no verify, just a phi. So theta third equal to negative of those phi. Actually this is 0, and plus phi 1 plus phi 2, and plus 180, and plus k times 360, right? 360. I don't need these. And they are okay. I think this is a verify, right? I have that verify. I still use this verify. So this will be verify plus this is verify, right? This is also verify, right? So this angle will be verify plus 180, right? And this one, this is 180. Here's verify. So this is a 180 minus verify. This is phi 1, this is phi 2, and plus 180. You see, these two cancel, one positive, one negative, and 180 plus 180, you go back, it's 0. So answer is just 180. 180. So it's here. This is a phi third. Yeah, phi third. Just 180. Go along this way, no problem. All right. Okay, now we can try double. We can consider GS square. g1 of s equal to g squared. Then what will happen? So actually they have same poles and same zeros, but each has multiple 2, right? Multiple 2. Then we will have, you see, 4 poles and 2 zeros. So we will have them going up and down. 2 directions go to infinity. Right? 2 directions go to infinity. And the center will be, okay, so here's -1, this is -2. I need to add them all together. So the imaginary part cancel. So 4 of -1 and 4 of -1 plus 2 of -2 is 0. So the center is 0, or center is here. Center is here. So it will going up along the, here's a 0. Here's a 0 along the imaginary axis, going up and down. Then totally we have 2 going up and down, and the other 2 will go to here. So most likely it will look like this, right? It will look like this. It will look like this. And this is a departure, right? Departure here. Departure. We have 2 departure at each point. And what is this departure angle? What is this departure angle? You can calculate similar. We call this is a departure from. I say this is a -1 plus 2j, right? That is a theta. I say it's a theta. Now it's a 2 theta, right? 2 theta. 2 theta equal to. 2 theta equal to. Okay, I have 2 90-degree here, right? This is a phi 1 and phi 2. Actually, same point. Both equal to 90-degree. And 2 circle here. So I have ver phi 1 equal to ver phi 2 equal to that ver phi. Ver phi is a same angle. Right? Okay, so 2 theta will equal to 2 of ver phi minus 2 of 90-degree, and plus or minus another 80-degree plus 3k times 360. And k will equal to 0 and q minus 1. This is also already q minus 1, so I have k equal to these 2. Okay, so phi will equal to ver phi. I use a plus here, okay, minus 90-degree, right? Oh, actually these 2 cancel. I use plus, then they will be cancelled, right? They will be cancelled. So ver phi plus k times 180, right? K 180. And k equal to 0 and 1. So what is that? It is just this way. Connect this. This is ver phi. So ver phi itself, or ver phi plus 180. So like this. This is a tangent line, right? Tangent. This is a curve. According to this point, I have tangent line connected. So one direction is here, one direction is here. 2 directions. And similar. This place, the direction will be 1 is here, 1 is here. So the curve will be like this. I have cross 0. So the curve will be like this way. And here we'll go to positive and negative infinite, coming up and down. Alright, this is a departure. And the negative side, only thing is you need a, actually we say it's this way, right? That is 180 divided, you remove this 180. You remove this 180. So here you need a plus one more, minus 90-degree here. So minus 90-degree, minus 90-degree. You have these 2 directions. This is a coming to. This is a departure, and arrive. So for negative k, it will go this way. And similar, you can calculate this way. This at this 0, you have 2 departure arrival direction. It's coming down or up, right? This arrive direction, and departure will be this way. Departure will be this way. All right. We can use MATLAB to see how it looks like. I open the. I use as equal to this one, and I use a g, which is a numerator is s plus 2, so I have 0 at negative 2, and the denominator is s squared plus 2 times s plus 5. Then we can see the rule locus of G. It's this one, right? And we can see the negative side. Rule locus G, and hold on, and the rule locus G squared. No, sorry, negative G. Okay. Oh, there be circle. The blue. Now see the mouse. I move this direction. I click. Yeah, this side is for positive G. So this is departure direction, right? Departure direction. And this place will be negative K. So this is arrive to the pole. All right, the direction they are same. Just add 180, add or minus 180 degree, right? Two directions. And 0 is here. Departure is this direction. It's 180, and arrive should be 0, right? Okay, this is 1G. All these zeros and poles, just the single one. The multiple is 0, and we can try. Let me close these, and we use square of it, no square of it. Oh, it was times 2. Square of it. Okay, now it looks like this. Make it larger. This place, you see this place? This is one of the cross. Should be 90 degree each, or the scale is different. In the real exercise here, you see the unit like 0 to 1 is here, and the image size is shorter, 0 to 1. So it looks not exactly as 90 degree, but it should be 90 degree. These 4 directions, 90 degree. This one is a departure, and red. This one is also departure, and going up is a. Let me see. Oh, going up is a departure. Going up is departure. We can compare we have obtained in the. Can I have both? Here. Have both. Yeah. This one here. This is a curve for the positive K, right? Positive K. So it's this one, positive K, and departure up and down. And the left and right, they are the arrival direction, arrival to this pole for negative case. And for this circle, this 0, up and down, they are arrive, right, for positive K. And then along the real axis, they are departure for negative case. From negative infinite, coming up to 0, and then positive, right? Things like that. Okay, this is 2, multiple 2. We can try even more, like for example, I want 6 here. What can we have? Maybe too much. 5. Alright, so the each 0, we still have that 3 points, 1 zeros and 2 poles, but each have multiple 5. What it will be. to come back. I want, let me see, I want only see from negative, like negative 8 to positive 3. And this side is positive negative 6 will be fine. Right. I use x as x side from negative what? I forgot. I just negative like 8 to positive 1. All right. And negative 8 to positive 1. Negative 8 to positive 1. This is for x, and y from negative 6 to positive 6. X, sorry. S. Yeah, we have larger. Okay, you see, we have still, this is the departure point, 2 cross, and this is the arrival place, 0, and each has multiple 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 coming out from here. 10 coming out from here. Yeah, like this way it's more better. Makes a round circle. Okay, the scale now is good, right? And we can see, make it large. This point, you see, all the directions. Yeah, this should be same point, but it is some display arrow here. Should be same point, and all of them start from here with a equal likely angle, right? Equal likely angle. Yeah. Okay, so this is arrive and departure from 0 or poles, right? Arrive, departure from zeros or poles. Right? That is me. Okay. Then we consider the break point. Actually, break point is also kind of point that you have lot of curve go to the same point and leave it, right? Now the direction on a break point. On a break point. The break point is the thing happened where it looks like this, right? You have break point. So yeah, we already have one, right? We have like here. Do we have break point? Yeah, this is a break point. See, we have 2 break point here. All right, I just see the positive side. Let me just look at the positive one. Locus. Just G. Right, this is break point, right? At break point, we will have like this one. I copy it to my notes. Okay. And this one. And this one. Okay. Looks like this, right? We have this one. And this is break point. This is break point. Break point. And here's a break in. Here's a break out. So we will have break in and out direction. In and out direction. Then, okay, you can think like this. You will have some K here, right? For that K, you have 2 poles. 2 poles here. So here it should be a pole with multiple 2. This is a pole with multiple 2, right? For this example, maybe different more multiples. For this example, here's a break point. It is a pole with multiple Q. Q must be a number larger than 1. If Q is 1, then it is not break point, right? Break point at least multiple 2 or 3. Then there are total 2 Q directions. two directions. Q for Q direction for break in, and Q for Q other direction for break out. And these two directions separate 360 equally. Yeah, equally. Oh, it should be two letters, two words. Anyway, I put them together. Yeah, should be, yeah, like this multiple two. Then you have four directions, and these four directions will separate 360 equally. So it must be, because we know this is a 180, this is a 0, and so these two directions must up and down 90 each, right? Yeah. If we have 3 or more, then the angle will be different. Now we can consider different examples. We can see, for examples, I use a different G. I use a G equal to, maybe I need keep this G. I use another G. G1 equal to, I use 4 poles. Suppose we have 4 poles. So it's 1 over one pole at S, another pole at S plus 2. Negative 2 is a pole. And I also need 2 poles, positive and negative, in nearby negative 1. So S squared plus 2 times S plus, okay, I still use 5. What will happen? I use this G1, and then rule locus, G1. Now can you imagine what it is? We have 4 poles, right? 4 poles, no zeros. So we will have 4 directions, something like that. Let's see example. G equal to 1 over S plus 2, S squared plus 2S plus 5. And we have one pole here, this is negative 2, and poles here. This is a 2, right? This is 2J. Okay, so we have 4 directions. We need 4 directions go to infinite, right? 4, so equal likely should be 90 degree, and start with half of 90 degree. So this direction should be 45 degree, right? Then how to go to there? Should be symmetrically. Okay. Can you imagine? Yeah, we can just look at the computer. Okay. What will be the result? You see, 4 directions like this. So we start from these 2 0 poles, go into the middle point is a negative 1. Then here is a breakout point. Then coming up or coming down. The upper branch will touch with another pole going down from the top one, and then with these two connect together. They go together, then separate left and the right. Similar, this place is similar. So the break point looks like this. We have 3 break point, and each break point you have 2 in, 2 out, right? So each should be multiple 2. Yeah. You can calculate the direction, use the formulas. You will get same result. You can also just look at them. You will have similar thing. We can try. Break point. Okay, first find the break point. Oh, you need to calculate. Find break point. Break point, we need to check the check the characteristic polynomial. There will be s plus 2s squared plus 2s plus 5 and plus that k, right? This is the denominator of the whole overall transfer function. I want this one equal to 0 and the derivative of it as 0, d over ds, and okay, so what it is, let me times it together. This is a s plus 2 times, so it is a s cube, right? S cube, but another more s, so s fourths, and s squared term, this is s squared, this is another s squared, so 2 and 2 I have 4s squared, 4 of s squared, but it should be cube. The s term, s5, 2 and s, so 5 and 4, and I have 9 of s should be squared, and the constant should be 10. Okay, am I good? Okay, it's good. It's 0. Then this derivative no k, right? After derivative I have 4s cubed plus 12s squared and 18s plus 10 equal to 0. And we know here should be a breakpoint, so it's -1, right? S is equal to -1, so -1 should be s plus 1. So I can try s cubed plus 12s squared plus 18s plus 10 divided by s plus 1. You can see the result. This will be 4s squared, 4s cubed plus 4s squared, then the s squared, then 18s, right? Times plus 8s, I have 8s squared plus 8s, I have 10s, and here is plus 10, so plus 10, 10s plus 10. Okay, so it is s plus 1 times 4, I move 2 in front, 2 of s squared and 4 of s plus 5 equal to 0. So this one give us, can we have s? This is a 2 of s squared plus 2s plus I move 2 and 1 and plus 3. So s squared plus 2s plus 1. So this equal to 0 give us s equal to -1. And this equal to 0 give us this equal to 0 give us this equal to -3 over 2. So s equal to -1 plus or minus square root of 3 over 2j. Okay, so we have 3 breakaway point. This one and the 2 here. Then the angle. How to calculate the angle? You still need angle, right? We know each is multiple 2. Each is multiple 2. So here we have 1 is here, 1 is here, 1 is here, 1 is here, and then breakaway point is here. We check this one. This one is I use a square for these 2, and at the same k, actually totally, because the system has order 4, right? System has order 4. So for every k we will have 4 poles. So at this point, that is for some k, right? For some k, for that k we have 4. Actually, this is another breakaway point. Okay, we have these 4 points. So these 4, they are poles of T of S with same k. Yeah, right? For that k we have these 4 points. And then how to calculate the angle? You think this k is 0. You change the kind of you think this is 0. Usually we think this is k, right? You think this is k equal to 0 is here, and this side is k less than 0. This side is k positive 0. Now you use that k with same k equal to like k1. Then this is k1. Then you consider this point, left and right. This is arrive, this is a departure, right? Arrive and departure. Arrive and departure. So arrive work this direction, and departure work this direction. And you use the same formula with the poles, with those poles. The thing is, like you have 1 square here, 2 square here. This is a 90 degree. This is another 90 degree. This is phi 1 and phi 2. Phi 1 and phi 2. Here's Q is 2. Q is 2. Alright. You want to know the angle set. I think it's for arrive. So Q times arrive. Arrive, you need to consider some point S. Go to here, right? So this is theta arrive. Theta arrive. Theta arrive equal to no 0, no verify, only phi. So 2 is phi 1 plus phi 2, and oh no, this is arrive should be negative. No phi. Verify is positive, right? Phi is minus with the formula. We use the formula for departure from pole. From the pole. No. I want departure. Oh, departure. I confused. Arrive to a pole. Arrive to a pole. Yeah, arrive to a pole. Arrive to a pole. Just minus no 0. No 180. Right? No pi. We'll just have that. This is an example. Departure. Arrive. Yeah, here. Arrive to pi. So it is some verify minus phi, then plus 2k pi. Alright. So here's a 1 phi, then plus 2k pi. This one. Q is 2. Q is 2. So we have arrival equal to 1 over 2 times 90 is 180 plus 2k pi. 2k times 360. Right. So it is negative 90 plus k times 180. So you see, negative you will be negative 90, and plus 180 will be here. So we have two directions, right? This is the circle. This is the cross. This is the rectangle for the cross. So up and down. So arrives up and down direction. We have two directions, up and down to it. And leave, departure. Departure here you need for departure. Use the formula for departure from a pole. So Q departure, theta departure. Here's Q is 2 or equal to that formula. Departure from this is arrive. This is departure. Right? Departure from pi. Departure, so it's a verify minus phi minus pi, then 2k pi. So this is a verify 0. go to 0. Minus, I have 2, phi 1 minus phi 2, and minus 180, the pi, and plus 2k times k times 360. Okay, so we have the departure direction, this angle equal to, this is 0, this is 90, this is 90, so it's 180. So minus 180 minus another 180, so 360, it's nothing, right? 360. Okay, I divide by 2. I also divide by 2, so it's minus 180. And this is plus k 180. Yeah, we have this one. Okay, so it will be negative 180 here, and plus k of 180, so plus 180 plus 180 plus 180, whatever. We have two directions, and now we know the overall we have cross here, cross here, cross here, cross here. Then the locus where it looks like separate like this. Now we have this one, right? And this will go, this is asymptotes, they go to infinity, and this point is a negative 1 plus square root of 3 over 2j. This is a negative 1 minus square root 3 over 2j, and here is just negative 1. Here's a negative 2. Here's a 0. Alright, so we have the whole graph looks like this. And if we, similar thing, if we do square, what will happen? Now this is g, right? This is g1. This is g1. This is g1, locus of g1. If I square g square, what will happen? Oh, no break point. Am I good? G1 square. Oh, G1 square, no square, no breakaway point. Anyway, yeah, the breakaway point is hard to determine. Yeah. Okay, so this is for the, anyway, this we already have example, right? Yeah, we can. So we can have we already have the formulas how to find the angle for break in and break out at a break point. And I think almost done for the rule locus. Oh, we have one more topic. If we add a 0 or remove a 0 or add a pole or remove a pole, what will happen? Whatever happen? We consider this. Okay. One more thing. Okay, another thing. Add or remove pole or zeros. What will happen? When you add a pole, you will have one more rule locus, right? One more locus, one more curve start from that pole. And you remove, also you will remove one locus. Now we can see, we can look at the graph. I have G, right? I have G. I have this G, G1. No, I want G. What is G? G is symbol. Okay, this one we have 2 poles and 1 zero, right? Okay. G. Okay, we have this one. We have 2 poles and 1 zeros. Okay, if I add a pole, what will happen? Add a poles. Add a pole on it. Add a pole times s plus 3. Add 1 pole. Oh, times add 0. Okay, I add 1. Okay, add a pole. I need to add a pole. Sorry. Divide it. Add a pole. Add 0 is also a problem, but prefer start from add a pole. Now I have 3 poles and 1 0. So I need 2 poles go to infinity. The first one I have 1 pole go to infinity, right? Looker go to infinity. Now I have 2 lockers go to infinity. It's up and down. Okay, add 1 more. This is a 3. Add okay, I just times double it. Now I have 1 more pole, right? I have double pole at 3 and 2 more pole. Original I have now I have 3 poles, right? 3 poles. And I have 4 poles. This place I have 2 poles here. At 3 I have 2 poles. So totally I have 3 poles. I have 4 poles. Yeah, 2 here and 1 here, 1 here. I have 4 poles, 1 0. So 1 0 cancel. The other 3 will go to infinity. Alright, I get more. I get 5. Like totally we have now I have 7 poles, right? 7 poles, 1 0. You see, we have more curve go to infinite. Alright, so what happened here? We look at them together. Add row, add poles. So like we have these. Suppose we have these, like this way. We add a pole. This one I have 1, 2, 3, 4, 5, 6, 7. I have 7 direction, right? 7 direction. Now I will change to be 8. 8 direction. So it looks like this. So the things looks like this one going down to here, going down to here, going down to here, going up to here, and this one is also going down to here, going down to here. It's going down to here, and this one separate. You go to here. So every time when you add a pole, the thing is like you just pull it to this way. So all the root lockers move towards the right side. Yeah, lockers. Move toward right side. Yeah, they move toward the right side. And oppositely, if you remove poles, they will go to the other side. And you add a 0 will be similar. The 0 will not go to infinite. The lockers will start from go to infinite. Right, start from pole go to infinite. Now you have 1 more 0. That lockers will go to 0. So you will have less lockers go to infinite, and then you will move left. So add poles similar as or remove zeros. That means the poles where the lossy, you will have more lossy go to infinite, so lockers to move towards the right side. Asymptoters, more asymptoters, more asymptoters. Yeah, we have more asymptoters. And if we this add poles, if we remove poles or add zeros, then we have less asymptoters. Asymptoters, not symptoters. We have less symptoters, and lockers move toward left side. Go left side. Alright. Yeah. You just go back. Just this one go to this way, right? Go back. Reverse way. Reverse way. Yeah. can consider example, like example. I have g of s, which is 1 over s and s plus 2. Then the rule locus will be or looks like this, right? We have 1, 0 as a pole and the negative 2 as another pole. Two poles, they will go to infinite, so it should be up and down, right? Up and down. And the center will be summation 0 and summation of these and divide by 2, right? 2 directions, so it's a negative 1, so it should be negative 1. Center here and up and down. Direction is up and down, so must be straight line like this. This is rule locus. If we add a 0, g of s equal to, for example, s plus 3, s and s plus 2. Then we have cross and circle. Then the rule locus will be, looks like this. So you see here the curve occupy this area, right? Now the curve totally moved to the left side. Here's empty, no more here, right? No more here. The original one is like this. Now we do not have this part. Okay. So from here to here, this seems like use a controller, right? I have a controller by s plus 3. So this is a derivative. This is a proportion. This is PD controller, right? PD controller. Add a PD controller. At the PD controller, I have, and I say this is G1. Okay, G1 is this. So it looks like this. Okay, if I add more, add a pole back. This one, add a pole. Then I can have like s plus 3 over s and s plus 2 at times s plus the larger one, like 6, 7 or 6. Then I have cross, circle, and another cross like this. Then what will be the rule locus? Okay, so we have two curves up and down, right? Up and down go to infinite. And the center will be 0, negative 1, negative 2, negative 7. We do summation of the poles is negative 8, and here's 2, so totally negative 6. 6 divided by 2, so it's negative 3, and negative 3. Here's negative 3, and negative 3 coming up and down. So yeah, it should be looks like this. And here's like this. Alright, so the curve will looks like this. So by add the pole, this one coming back to here. Okay, if you add one more, like s plus 2, add one more. Add a pole more. Add more pole. Add a pole. S plus 3. I have s plus 2. S plus 7, I give one more s plus 5, and I have cross 0. This is negative 1, negative 2, negative 3. This is 0. Sorry, this is 0. Oh, this is not negative 0. Yeah, 0 and negative 2. 0, negative 2, negative 3. Oh, this is not negative 3. Sorry. Yeah, 0 and negative 2. And this is negative 3. Okay, so this I do wrong calculation. So the summation 12 minus 3 should be 9. So this 0, 2, 7 should be 9. 9 minus 3 should be 6. 6 divided by 2 should be still negative 3. Anyway, yeah. Okay, here now is a negative 0, negative 3, negative 3. negative 2, negative 3, then negative 5, negative 7, cross, cross. Now I have 3 direction go to infinity, right? 3 direction go to infinity, and the center will be I do summation of poles is negative 14, and this is negative 3. I do subtract at negative 11 and divide by 3. It's negative 3 dot something. So here should be here. This should be the center. So 3 directions. One is 1, 2, 3, 4. I have 3 directions. One is go to here, one is go to here, and one is go to here. So go to this direction should be this one, right? And these 2 now most possibly look like this, and here will be another path look like this. So rule locus like this one. All right, you see, for this case, the rule locus even go to the right side, right half plane. So you can imagine for logic K, the system where the feedback system will not be a stable one because this kind of things. We have some restriction on K. K cannot be too large. Right? For this case, you can use any K, or the other than zero, right? All the possible K's, the system can be stable. And this one is similar. All the other K's could be stable. But here you have too many poles, so some go to the infinite. Then this is for logic case, this is unstable. If you have a system look like this, maybe you want to add some more controllers with some poles with some zeros to move these to the left side. Yeah. Okay, that's all for today, and see you next time. Okay, 2 more minutes. Sorry for that. See you next time. Bye bye.